Hello and welcome to our talk. I'm going to guide you briefly through parts of our paper, Novel Goodness of Fit Tests for Binomial Count Time Series, written together with Christian Weiss, Carsten Jentsch and Maxime Femoville. In this article, we consider goodness of fit tests for time series with bounded counts. Having bounded counts meaning having range of non-negative integers 0, 1 and so on till n with a fixed n, and n is known. We are going to test the null hypothesis of a binomial marginal distribution. To be precisely, under the null hypothesis H0, we assume that the data generating process has the binomial marginal distribution, and the pair legs of xt and xt minus h with the leg h have the bivariate binomial distribution of the type 1, with rho of h being the autocorrelation function, and it satisfies the mixing assumptions required for the center limit theorem by Ibragimov. We are going to present two general approaches for constructing moment-based goodness of fit statistics. First one is based on higher order factorial moments, and the second one is based on a so-called Stein identity. There are various models satisfying such assumptions. For example, IID binomial. We are going to look at the binomial R1, which satisfies it. It was introduced by McKinsey. It has two parameters, alpha and beta, which involve two other parameters. So here, first part, this is binomial thinning. It is not like, it's not quite like multiplication. If we condition the whole equation on xt minus 1, then this would be a binomial random variable with the parameters alpha and the other parameter xt minus 1. We can look at this as so this first term could be interpreted as a survival of the previously observed counts, or if you think in objects, so some objects staying active with probability alpha, and those are objects being activated with probabilities beta. So all thinnings are performed independently of each other. Mathematically, you can define that as a sum of independent identically distributed random Bernoulli random variables from 1 till xt minus 1, and here the sum till n minus xt minus 1. The example we looked in our paper was a group of 70 countries in the euro area, and the question was how many of those countries showed stable prices, so inflation rate below 2%, and we observed counting from 0 till 17. Such examples are modeled with binomial autoregressive 1 model. Lect pairs follow bivariate binomial distribution, which arises from the sum of IID bivariate Bernoulli distributions. The marginal distribution of this process is the binomial distribution. For abbreviation, the factorial moments defined like that. The statistics rely on factorial moments we defined like this with different R and S. Under the null hypothesis, this statistic equals this to this, where R, S, N are known and fixed. Let x1 till xt be a time series of bounded counts. Capital T is the sample size, not to distinguish with the name of the statistic. This is the name T hat. Then the sample counterpart is given like this. If we plug in R equals 2, we get the dispersion statistics, and which is the main competitor to all other statistics, and we looked at skewness statistic and kurtosis statistics, both of them. So to derive the asymptotic distribution of such a statistic, we first need to derive the asymptotic distribution of this term involving factorials and factorial moments here. This one, with the help of a center limit theorem by Ibragimov, we can show that this converges to the multivariate normal distribution with the matrix sigma. And then we apply the delta method with the function g from going from r to the power of 3 to r, which rebuilds the initial statistic t. And d here is the gradient of the function g. The theorem. Let the data generating process satisfy the aforementioned assumptions, then the distribution of the statistic can be approximated by the normal distribution, where the bias corrected mean, mu, is given like that, sigma like this, RKL defined in this way, where pi is a parameter, and autocorrelation functions. For different models, we plug different autocorrelation functions, which simplify it in bar 1 case to that, and ID case further simplifies to this term. Second block of our talks are the statistics based on the Stein identity. Stein derived identities to uniquely characterize a given type of distributions. Such identities exist for normal distribution, for several discrete distributions. We also derived tests based on the Stein chain identity for Poisson distributions, with joint paper with Weiss and Jentzsch. In particular, for binomial distribution, if x is binomial, then this equation holds, this identity holds, so long as both expected values exist. If we divide this through each other, we get this one, the statistic and the sample part, and if this deviates significantly from 1, then we can conclude that we have to reject the H0 hypothesis of binomial counts. Here f can be interpreted as a weight function. We have derived asymptotics for the exponential function of minus x. For different functions, you might need the parametric bootstrap, which so let this theorem, let the data generating process satisfy the above assumptions, then this distribution of the statistic can be approximated by normal distributions. I haven't posted here sigma ij's because they're to have a lot of terms and involving the generating function psi and the derivatives. Psi u is the derivative in the direction of u, and the autocorrelation function. Coming to simulation and conclusions, we have done two-sided tests with nominal level of 5%, different sample sizes, 10,000 replications per scenario. Simulated sizes were generally close to the nominal level of 5%. Some scenarios were experienced oversizing and undersizing. We have done parametric bootstrap, in which undersizing was avoided. Simulated sizes power. We had for different scenarios different good statistics. Sometimes the dispersion index was a really good one. If the variation is caused by zero inflation, for example, then the Stein statistic is clearly superior. So for different alternative scenarios, there was a statistic which proved to be advantage over their competitors. Here are some references, and thank you for your interest.